Hello and welcome. I'm Bill Wake. We're here working on the Shunting-yard algorithm by Edgar Dijkstra. It's an algorithm to convert from infix to postfix, and we're also working on visualization. I've been playing with some ideas around algorithm visualization, trying to get some visualization without modifying my algorithm too much. So here's the problem statement. We have an infix expression, just a normal kind you learned in grade school, 3 plus 4 times 5 minus 2. And we want to convert it to postfix, 3, 4, 5 times plus 2 minus. Postfix says, give me the root, give me the left subtree, give me the right subtree, then give me the root. So you can see 3, 4, and to evaluate it, we push those on the stack, 3 and 4 on the stack, 5 on the stack, times we multiply the 4 and the 5, so that gets the precedence. And then plus we add the 20 to the 3 on the stack, 23, 2 on the stack, and subtract 21. It's a way of translating, and it comes from the algorithm comes from a paper Dijkstra wrote in 1961 on Algol 60 implementation. So here's the view of it. Basically, on the right-hand side, you have an infix expression coming in. We're using a queue. It could be a sequence, similar idea. And so the letters come in, or the characters come in, 3 plus 4 times 5. And then we make a decision. Are we going to send it straight to the output? Are we going to push it on the stack? Or are we going to pop things off the stack? The algorithm says if you have a number or a variable, it just passes right through to the output. So 3 plus 4, 3 passes through. When you have an operator, you get up to the stack and you decide, hey, are the people on the stack higher precedence than me? Then I should pop them off. Okay, so if I had 3 times 4 plus, and the plus was sitting here, and the star was on the stack, we'd want the star to come out first because it's higher precedence. Eventually, we get rid of the higher precedence operators. We push our current operator and continue on character by character. And at the end, there's going to be some operators on the stack, presumably, and we pop those off. All right, and we've basically done the first rule, numbers passing through, and the last rule, pop the remaining stuff, but we haven't made any decisions about the precedence. Okay, so let's go to the IDE. Where did I leave things? Okay. Sorry, this should be on chat. That's better. All right. So let me just kick off the tests. Well, yeah, let's kick off the tests. See, we didn't check in a lot yesterday at the end. All right. Unfortunately, it takes a moment to start up the simulator when you don't do that in advance. All right, we'll just walk through the code a little bit. All right, so the counter is just I created it for Towers of Hanoi. It's an observable integer, and then we have a queue that we built yesterday. We make it an observable object, so this is how the algorithm visualization can see it. It has a member published, the queue, and whenever we do anything, the event, the publishing observer event system says, hey, I'm about to change, and lets the UI know that, so the UI can keep track of which regions need to redraw. And the other thing we do is we have to make sure that notifications happen in the main thread. So we're doing that by making sure that every mutator action, like adding or removing, runs in the main thread with this little helper method. And if it's not a mutator, it's just more of an observer or an accessor, not just strictly accessor. I don't know. The terminology has kind of been taken over by simple accessors, but if it's an accessing function or a non-modifying function, then it doesn't need that threaded stuff. All right, and then let's see. Let's take our app. It's this is Swift UI. It sort of builds everything up as text, and it says we're going to create a content view that holds onto a prefix converter, and prefix converter is our main class. All right, the tests do run. That's good. Okay, so where's prefix converter? There it is. And that thing. All right. So we've got the output queue, the stack, and the input queue. We have the opportunity to clear them, or we have this algorithm that says convert an input string into the output queue. Okay, so we run through, while the input's not empty, we're going to take the front symbol and remove it, just hold on. If it's a number, we're going to add it to the output queue automatically. So that's that first rule. Numbers just slide right through. If it's not a number, the only choice now is an operator. And so we push it on the stack. We're not looking at the precedence of anything on the stack or is the stack empty or any of that stuff. We just push it. And we repeat that for everything on the input. And then at the end, we dump out the stack. While the stack's not empty, take the top of the stack, add it to the output, and pop it off. Now, I'm going to raise these sleeps. They seemed a little fast to me. And I don't know, maybe there's a way to make this better. It would be nice if the sleep was a little dial somewhere I could control. But let's commit it while we're green. I guess I'll forgive the delay. So I guess we implemented the Q view and visualization. And a minimal algorithm. All right, and we'll run just to kind of see where we are. So for our example, we'll take 1 plus 2 times 3. I'm using different digits so we can keep track of which thing is which, even though we're pretty sure digits flow left to right, so it's probably not much of an issue. But 1 plus 2 times 3, since the times has precedence, we expect the output to be 1, 2, 3 times plus. All right. Once again, the simulator is a little weird, a little flaky here. It should eventually draw our stuff the proper sideways, but we may have to wake it up. Let's see, device. I can rotate right, rotate left. I don't know if that'll help anything. No. It's just slow starting. It's not hitting my input or my sleeps yet, so like, hey, there we are. All right, so very primitive, I admit. But we have the Q on the left of the bar, the stack in the middle, and the Q on the right of the bar. So 1 plus 2 times 3. Go. All right, that's still cooking along, isn't it? Dun, 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 dun. That didn't seem like a second to me, or 2 seconds. All right, let's, because I'm suspicious. Next time we run it, we'll run it with a 10-second. Okay, so 1, 2, 3 times plus. That's very good. All right, but what 1 plus 2 plus 3? Okay, we had 2 things on the stack at one point. It looks all right, 1, 2, 3 plus plus, but it really should be 1, 2 plus 3 plus. And you can see what's going wrong if 1 times 2 plus 3 should definitely be 1, 2 times 3 plus. And it's 1, 2, 3 plus times. So we haven't dealt with precedence. We also, I don't know if we'll get there or not, but we haven't dealt with let's see, 3 to the 1 is 3, so 2 to the 3 to the 1 is 8. 2 to the 3 is 8. I guess I got to do something different to 2. Okay, 3 squared is 9, so this should be 2 to the 9th, 512. And if it does it wrong, it does 8 squared, 64. Well, I guess we won't know. Yeah, again, the operators are the same, so we can't tell. All right. Let's run it again, because if it's not sleeping, we'd like to know that. And that's sleep. Okay. 1 plus 2 times 3. Am I? Oh, I got a missing 0. Okay. Okay. I think we can put this back to 2 safely. All right. Boy, even with those little separator bars, I still mess it up. It's the programmer's lot, I guess. Okay. But anyway, I'm raising that to 2 seconds. I think that'll be more visible to us. But let's focus on prefix converter. I'm going to close the other tabs, and let me just open to do as well. I don't want to lose that. Okay, so we want to do left associativity with precedence. More is like right associative. Okay. So let me go back to the algorithm, wherever I left it. All right. So numbers pass through. We're good. At the end, pop everything off. We're good. But now what needs to happen is when an operator comes in, if the stack is higher, then we want to empty the stack. Well, no, we want to empty it while it's higher. Okay. And then push. And I guess we haven't addressed when it's equal, so we'll have to think about that too. I guess it's, well, if it's left associative, 1 plus 2 times 1 plus 2 plus 3. Well, let's do 1 plus 2 minus 3 so we can tell them apart. We expect 1, 2 plus. So the plus must come out when it's sitting there with the minus with an equal precedence. So we'll pop while the stack's precedence is it is higher. Okay. Minus is not higher. It's the same. So I guess we need to, while it's greater or equal. Okay. And that's the thing that will change with associativity, because associativity controls operators of the same precedence. All right. Let's see. So let's make sure we have the test case for 1 plus 2 times 3. Converter tests. And all right. So we haven't done that. We've manually tested it, but let's lock it in. So 1 plus 2 times 3. I don't know if this is. Yeah, I don't know if I should. Well, what we're doing. The reason we're doing this is we're making sure the stack empties out at the end. So maybe that's the thing to say. Stack empties at end for 1 plus 2 times 3. 3 times plus and a star. All right, and I don't know, maybe my Q would be. All right, let's see if this runs. I think it should at this point, because we had to empty the stack. Actually, we had to empty the stack for 1 plus 1. So what's this a test of then? It's really testing well, I don't think it's the stack ending at the end is a side effect that we don't care about as a user. So let me find a better name. I think what we're testing is precedence. How about higher precedence on right side evaluates first or something? I don't know. Test failed. Ooh. Oh, it should be times plus. 3. All right, and I think we're. Yeah, I think we have some cleaning up to do. We'll start with some refactoring today. Still running. Okay, there we go. All right, I didn't hear anything. Oh, it's still running. There it is. Okay, cool. So let's rename this. Well, this one is, let's just say simple addition. This one is multiplication has higher precedence than addition. I think I'll take that name. All right, and what I'm thinking, well, I think there needs to be, I think we need to say that the stack is empty. Wake up, come on, Xcode. I can't type that long thing. Here we go. I think we want to say converter dot stack dot is empty. And this is assert true. And then converter dot input is empty. Okay, I think that should be true anywhere. All right. And well, let's extract what we want to say. So I'm going to say expected equals 1, 2 plus. Just keep it in the string domain for now. All right. And then let's say this is expected dot. Well, no, let's do it the other way. We have another output. It's output dot description. And I believe it puts it in brackets. So let's do it like this. Quote. And this is expected. Okay. If this test passes, I'll be happy. And what I'm planning to do is extract a little helper because I've got 3 things I want to assert on. Yeah, so this should be green by now. But anyway, let's notice what I've done is I've pulled anything out that varies up above this block. I don't have an extract parameter, introduce parameter refactoring in Xcode. So I do it manually. Okay. But we can extract a method here. And this is, I don't know, I tend to say check something. Check output, I guess. Well, okay. Now, now that I've done it, I see I wish I'd done it differently. Okay. Let's do it like this. Let input equals 1 plus 2. And this can be input. Expected is not touched above here, so we can move it up. Yes. All right. And let's extract this whole thing instead. All right, and let's check conversion. Okay, input expected. Okay, very simple checker helper method. And I don't know, it's like I say I want to tell a story. Usually I go top to bottom in hierarchy of stuff. Although it gets a little annoying to have to do that, to fit things in there, but that's okay. All right. So I've got this check conversion. Let's inline this. Do we inline? No, we don't. And then let's require the name to be there, just to cut out any confusion. Okay. Now you can see we're almost at a parameterized test. We'll stop there for the moment. But I think we can do the same call here, right? We've got 1 plus 2 times 3, expected 1, 2, 3 times plus. Okay. And that should be fine. One, two, three times plus. What's that going? 1, 2, 3 times plus. One, two, three times plus bracket. Expected. Oh, I need to convert. I should put it back and do it. I messed it up right away. Okay, but expected dot. Do I have a 2 array? Let's try this. I really should have done that before extracting. They really seem slow. Like, okay. All right. Sorry about the sloppiness. Okay, but at any rate, I think that's better. Is this one the same? Convert. Oh, it's clear instead of conversion, so we'll let that be. The other thing I sometimes do, well, and this is kind of on the way to making it parameterized, but I'm going to add a message of type string. I'll give it a default, and it should build. Okay, and then I can update them one at a time. This is simple plus, and I'm willing to use a little bit more cryptic language or more symbolic stuff. All right, just to make sure everything builds. Right. Okay. And then is assert equal, I think has a mode. Yeah, we can put a message at the end. And so we will put, excuse me, let's put message, and we'll at least distinguish which thing is which. Output I don't have to say message. Okay. This one is stack. And this one is input. Okay. Let's bust this. Let's just add an exclamation point in there and make sure we get a message as we expect. It might seem like I'm trying to be too careful, but you've already seen me mess up like 3 times this morning in half an hour. That's the 3 I know about. Okay, we expect a message from the first one and a failure, and I guess the expected output, probably the stack and input, will be empty. I wonder if one of these simulators is noticeably faster than the others. Wouldn't that be interesting? Okay, so we get 1 plus 2 plus is not equal to 1 plus 2 plus this plus that. Cool. Simple plus. Yeah. All right, so I'm gonna trust this. The message here is how about star greater than plus? Well, okay. That'll do for the moment. Okay, I keep, because the tests are slow, I keep wanting to stop and start blending in extra things and stuff like that. What I could do next, and this is like when I have a boatload of very similar tests, and that's what I expect in this situation, because we're testing this pretty simple function. I mean, simple from the outside. It's like I give you a string, you give me a string. Okay, there's lots of stuff going on in the middle, but there's only one. I mean, there's the clear method, and then everything else is converter, and we expect all the work to be in here. So it tends to be a situation that works better with parameterized tests. The sort of less parameterized version is this, where I just I kind of put them all on the same block, because they're doing the same thing, input to output. Give me a message if it's not right. Okay. Okay, so we're testing. Okay, so we refactored tests. All right, I guess we're still there. Okay, and let's look at our algorithm. What's going on? There we go. Nope. There's prefix converter. Okay. Again, Xcode's a little buggy. Okay. So, now I don't remember if Swift's switch statement is how fancy it is. Let's try a variation. So if we switch on symbol, can I say case symbol dot is number? And then case, what was it, default? Value type character, switch symbol. No, I can't do that. Okay, good try. Everybody's extending their switch statement so much that it seems like I should be able to. Well, maybe I should check that. Swift. We can have weird values and ranges. That's handy. I just felt like, I guess it's looking at symbol. I could do case symbol dot is number true false. Boring. Okay. I just wanted a bunch of, maybe ifs are the right thing. Okay. All right. So I think what I see going on is, well, it's either 2 or 3 functions probably. This thing, we just decided to give ourselves a string coming in. I could definitely see us passing in the input queue. So in effect, I think the core of this function is this. And I'm going to extract this as a method then. And I will let it be implicit. Let's take a look. Okay, it looks like it's got the stuff in it that we want. I'm just going to call it convert, and that's okay. And I really wish I could default this to the bottom instead of the top. It depends. It's like, do you like reading your math with lemma, lemma, lemma proof, or just, here's the high goal, here's the lemmas to do it. I don't know. I want to be consistent, if nothing else. Okay, so you give me the input. I'm converting it to a queue. This clearly converts it to a queue. I say clearly, right? Let's apply the, the rule of keeping things at the same level. This is convert string to input queue. How about move put string in input queue? I don't know. It's sort of, okay. This thing I want to be as clear as possible. Okay, so the other method I was thinking was maybe there's something here. Well, stack not empty, cop push stuff out. Okay, so let's call this pop remaining. Okay, and again. And the reason I want to be top to bottom is I want a story. The story of convert is put the string in the input queue and convert. And it's kind of implicit now, but maybe this should be set input. And a lot of times it's easier to extract it and then rename it than to stare at it until you get the perfect name. Okay. Set input convert. I can live with that. it's kind of a question of who owns this and why. And I feel like, well, you could probably make a case that somebody else should own those. It's like you give me the input, you tell me where you want it put, and we'll come back to that. Let's make a note. Um, the answer is probably. I don't know if I'm being too lazy, but I think that would be better, because I'm also imagining our later phase where we want to actually evaluate and we want output to feed in to our evaluation stack, and so we need output somewhere, and like we're going to go grab it from a prefix converter. That just sounds wrong. So same deal on the input side, like, hey, if you just gave me a queue, life would be better. I'd have to worry about the publishing and make sure the owning object publishes and we're monitoring it, and all that good stuff. But all right, while the stack is not empty, move this top to the output and pop it. That seems like a pretty good story. Okay, we're just dumping the rest of the stack out, and we're doing this in Swift, which is a moderately high level OO semi-functional language. You can imagine doing this in C or even assembler, right? It's just not that hard of a thing. It's like here's this is some little test for a pointer and or a location, and then this is access this and increment a counter over here as you move it. It's just a few instructions down at that level. I'm sure it's more from with all the overhead of Swift, but down at assembly language, this is a very tight algorithm. Okay, so pop remaining is good. This stuff in the middle, what are we doing? Well, one thing you can do, it's kind of like, which level should we extract at? I mean, you could argue to have extracted this. Input is empty. This is removing it, so it's the thing changing it. So I guess this whole thing is a thing. We want to find a better name for it, and again, I can extract it and then figure out what the name is. Okay, so this is I don't know, process input. That seems a little wimpy. But it's better than what we got. So let's run with that for now. Yeah, let's run with that. Okay. And then move that down here. I almost want to say process from input, pop remaining stack. I don't know. Sometimes these wordinesses aren't an improvement. Process from, but at least this kind of tells me what things are involved. Well, okay. You're probably screaming right now. How about process input to output, pop remaining stack? Okay. Let's run tests. And then I'm ready to make the next test. So I think 1 plus 2 minus 3 would be a good test. And we expect 1, 2 plus 3 minus. And we know from the way this is, it just pushes operators. It never decides to get them out before the symbols are dumped or moved. So I expect that test to fail. Okay, those pass. So we refactor extracted methods. All right, and now you can see this becomes a lot easier to write the next test. We expect plus to be here and minus to be here, because you should add the 1 plus 2 and then subtract 3. You know, I almost think maybe something like this, a little language. So I want to say plus star goes to star plus. Okay, so I'm trying to say the input order of operators versus the output order of operators. That may or may not be sufficient. Now the downside is we are running all our tests. I don't have a way to run one test, one line out of this. But I think the overhead is all in starting up the test system and all that. So I could create a separate function and then merge it in at the last second after we're happy with it. But I expect a failure, so come on. All right, 1, 2, 3 minus plus is not equal to 1, 2 plus 3 minus. Make sure it says that really. Yeah. All right, so we got a failing test. That's always a good time for a break. So let's take a 2 or 3 minute break, and I'll see you in a couple. Welcome back. All right, so this test fails. Why does it fail? Well, all we ever do is push operators on the stack and then pop them all off at the end. So that works sometimes, but it's not a solution for everything. Let me move this over to here. Okay, so we have to follow the rule. If the next operator coming in, we look at the stack, and if the stack's precedence is greater or equal, we're gonna pop. Okay. Um. So, what can we do? Can I extend the test to make it more clear that it's got to do the stack stuff? No. Well, let's just go with it. All right. So what happens is this is a number. Okay. Now we know it's an operator. Okay. So we've got to decide if well, basically, there's a while loop that's got to happen before. So while something, um, well, I'll say while true just to compile, so it stops complaining for a minute. All right. So while the precedence of the stack, okay, well, if the stack is not empty, um, we're gonna want to pop it. Well, and the precedence, but we got this. We know how to do it from below. Okay. And well, we're saying let's see. Make sure I say it right. While the stack's precedence is higher. Okay. I'll just call it precedence GE for now, greater or equal. Okay, and that's the stack's precedence versus the symbol. Okay, sorry, the precedence of the symbol on top versus the symbol in the stack. Say it again. The precedence of the symbol on the stack versus the precedence of the current symbol on the input. Right, and we don't have a method precedence. Let me put it right here for now. It's a private function. Precedence GE greater or equal. And we need a symbol 1, which is a character, I believe. And symbol 2 is a character, and it returns a Boolean. And I believe, okay, for now, can we get it? I want the current failure to be there. Cannot find character. Okay, so if the stack is not empty, if there's stuff on the stack, and the stack has higher precedence, then pop the stack. Okay, and I'm saying no, the stack won't have higher precedence. So my goal is to fail the test for the same reason. Okay, so I don't know. It's really kind of putting down a marker. I think of these tests as constraints on like a geometric problem. You know, of where can we fit our shape in? Well, it's got to fit in with the constraints it's got, and in that sense, I'm generalizing because I only have two operators right now. To put that in a loop, I'm generalizing, so I want to make sure the loop is terminating right. I guess it's not even terminating. It's like the loop so far is breaking the same way. It's not breaking the older tests. Okay, only the one test failed. All right, and it failed. It failed the way we expected. Okay, we still get the minus first. All right, so now, and how do I want to prove this? Well, if symbol 1, if they're the same symbol, do I want to say GE is true. Okay, 1 equals symbol 2. Thanks. Symbol 2. Well, then they definitely are the same. They're definitely greater or equal. Well, let's get the precedents. All right, so I'm assuming there's some table that tells me these precedences. And I'm going to create that table. Let's see, let precedence equal, and then it's a map. So we're going to map plus to 1, minus to 1. I think that's all right. Okay, let's make sure it builds. No. Cannot convert value of type character to string.index. Am I misremembering the map? Sorry, Swift map. Yeah, I don't want the map function. What? Is it dictionary the type? Yeah, thanks. Interesting, it tells you it's a hash table. I would have thought response messages subcode. Maybe I have to be a little more explicit. We're going from character to, I guess I can say like this, character to integer. Okay, ugly, and then we'll get it right. If it doesn't exist, just use a -1. All right. And I think this will pass our test now. Now, one of the things that strikes me about the original is it doesn't really error check that much. Um, and it's hard for me to know how much we should have, but there's definitely an assumption that the stuff coming in is good, and we wouldn't let you evaluate it if it weren't. Some other way it got accumulated. Well, I busted this. Oh, because we don't have a precedence for times. All right, let's add that. Maybe this is good that it's doing this. Okay, and I think we'll put similar ones together, and I'll let myself do these. Okay, so level 2, level 1. Okay, but yeah, it was a different test that failed, just to make sure I'm clear on that. And then let's run the visualization, assuming this passes. I'm going to pop back to the algorithm, pop the stack while the precedence is higher, push the operator. Okay, we should be doing that. We're popping the stack while the precedence is higher, and then pushing the operator. All right. Let's commit. Add support for precedence. And run. Okay, so now 1 plus 2 minus 3 should be 1, 2 plus 3 minus. Okay, 1, push the plus, pass the 2, pop the plus, push the minus, pass the 3, and clear the stack. You know, I'm wondering, I'm thinking visualization kind of wise, it would be nice if people would tell you what's going on while they're doing it. That would be interesting. Okay, I think our stuff should be, it should handle this. So 1, 2 plus 3 minus 4, 5 times plus. Okay, good. And now let's do 1 times 3 plus 2. Should be 1, 3 times 2 plus. You get pretty decent at these conversions once you've done it enough times. Yeah. Okay. Woohoo. We've basically got the support for precedence on these operators, and yeah. So, well, what I'm thinking on the visualization then is, I don't know, maybe a little label up here or down here, maybe down here that says what's going on, and so I want to say like this one is pass pass through um, pop higher precedent, or pop precedence greater or equal, pass through, push operator, empty operator stack, or something like that. Okay, so I'm modifying my algorithm, just to be clear. I'm saying, um, well, it's almost like a debugging thing or something. I don't know if I want to test it per se. Because normally, I mean, the problem is we don't control the inside of this loop. This is almost like a debug statement or a trace statement or something like that. Yeah, what can I do? I'm definitely modifying the algorithm. Okay, so let's just make a variable for it. And I don't know. I want to be. I'm gonna give it a little funky name. I think I'm allowed to put underscores in front. And it's gonna be nothing to start with. And we will update it at clear time for sure. All right, and what I want to do is I want to see the steps. Well, let's be artificial for a minute. Let's just start. Okay, and is done. Okay, let's get that much. All right, and so I'm saying that's going to be something we look at. It's only there for the purposes of visualization. So, it's, well, our content view. Yeah, I'm saying beneath the stack stuff, I want to put converter.face, and I'll put another spacer. All right, let's run it. I don't know if you've ever put little tracers like this in an algorithm before, but I've definitely done it when, like, sort of, if you're working your way through a finite state machine or something like that, there's sort of an implicit place you should be at these things, and it's handy to have that. So 1 + 2 - 3 - 4. Okay, this should be start. Yeah, 1 push, 2 pass through, and we expect it done at the end. Yeah. All right. So now I'm just like the use sleep. I don't know. I'm gonna have to find a mechanism to make this more general, but if the symbol is a number, then I want to, my phase is pass through. How about pass symbol through? I guess I can be explicit maybe. Okay. And if, and again, like every loop, I'm gonna otherwise I'm going to, my phase is pop Um, stack while precedence. Oh boy, I should learn to spell that word. Greater equal input. Make it that way. Pop while stack precedence greater or equal to input. And then I don't know if I want to sleep again. I really need to sleep between any two of these things, right? So let's. Okay, we'll sleep a second in there. And I guess I should. All right, and let's phase equal push operator. Okay. Then I go around the loop again. I got another sleep, so I'm okay. And then this one, pop remaining stack. Oh, and I got one of these messages. Ooh, what's that mean? I have to do this in the thread thing. Okay. Right. Let's see if it works, and then I'll clean up the stuff. So we'll go back to 1 plus 2 times 3. Oh, let's mix it up. 3 plus 4 times 5. And I'm expecting a boatload of warnings at runtime here, because I mutated something without doing it on the main thread, which is part of my codified rules. So start, pass 3 through. I'm liking this. I think I can leave out the word stack on that first one. Yeah, I'm happy. I wasn't expecting to do this, but I'm liking it. Yeah, so every one of those updates brings up a flag. All right, so let's define a method set phase. And we're just going to assign it. All right, and I'm going to do that in the main thread. Yeah, I wish it would realize like I have code. Okay, so run on main thread, phase equals new phase. Oops. Let's try it this way. Okay. Let's run that. We should get no runtime errors. Now, this comes back to
sort of a philosophy. Well, I would say we made a design decision that we're going to write the algorithm in Swift. I mean, I say we, but mostly me. I'm going to write the algorithm in Swift, and that means when I write a while loop, I have no control. I could imagine creating a little tiny language big enough to support some interesting algorithms, maybe just a little, simple types, if, while, function call, but something where I can get in and get control of things. This is, in functional land, right? This is kind of monads and stuff like that, where you've got these high level operations that can kind of control sequencing of steps and stuff like that. We don't have that here. All right, 1 plus 4 times 5 should be 145 times plus. Start, we pass through, we push empty, push the current operator, pass through the next field, pop for a while, nothing to pop, push star, pop the rest of the stack. We pass through 5. Was the pause for 5 long enough? Let's make sure we got the phases, the sleeps where we want them. Pass through. We definitely slept after that. Maybe 2 seconds would be better. Okay. And I've got this constant now. Let's pull that out. Let delay equal to 2 seconds. Oh, 2 million millionths of seconds. And I'm going to rename that to underscore delay. Stop. You went 32. Okay, fine. And again, I'm doing this for the benefit of my visualization. So I'm going to give it an underscore just to at least flag something's funny. Okay. This was the pass through before the pop remaining, so I can just do 1 plus 2. Or even 4 plus 5. 4 should pass through and pause, pop while, push. Oh. I did not see pass through. Set phase, pass through. I don't know if that's a problem or not. Let's look at this. Is there anything in here that makes me... The only thing was this. Do I want to... He's published, right? Okay. The only gap is, like, I don't understand when I do this versus... Okay, that's apparently wrong. I mean, my understanding is when phase changes, when the phase changes, there's a notification before it changes. Hey, I'm going to change it to pass through. We definitely saw pop while precedence. Okay, so, and this, maybe I just have to kind of pay attention to the sleeps and the sets. So after a sleep, we set the phase. If we go through this path, there's a delay. And then we set the phase again, and then there's another delay. So there's always a delay after a set phase. And before, for that matter. Okay, I don't see anything funny. All right, let's commit. Add a phase display on visualization. So maybe I need to, like, obviously these things sitting around. I mean, they're meta to the algorithm, right? So it's like I could see modifying the algorithm to. I almost want to give it an object. I know. I don't know what to call it, like a monitor or something like that. Proctor, thinking like an exam, but somebody. It's like we're just letting them know we got there, kind of thing, and we're slowing down on their behalf. So it'd be nice if there was some object that was like visualize or something, or I don't know. And you want to delay, you say visualizer.delay. And you want to set the phase, you tell visualizer.phase. And we make it a function of the outside world that our algorithm is modified to talk to. Rather than, like, if I go to the next algorithm, right, I'm going to have to re-implement a phase variable and a delay and hook it up and all that stuff. I would really rather not have to do that. Okay, so we're getting outside of the algorithm itself now, but I think that was an improvement because I really get a sense of what the algorithm is doing a bit more. If I knew the algorithm a little and I could watch this trace, I don't know. I can't help think of, like telling your kids, hey, call me when you get home, whatever. It's that kind of stuff. We're asking for a little bit of monitoring capability, and it's meta to our algorithm, but if we don't have the tools and the language to kind of inject these things, which we don't in Swift, then we've got to modify the algorithm. Now I say we don't, but like, I don't know, could I define my own if operator, and my own while loop? I don't know. You give me a closure, and I repeatedly call the second closure. While the first closure is not a false, then I call the second closure. I don't know. And then I could say that every while loop has a delay on it, and if you want to, you can attach a phase to it or something like that, a phase inside it. I don't know. Okay. Let's focus on our algorithm though. I don't know how much to drive down, but I mean, this is it's like I want to call the phase pass the symbol through. That practically tells me the name of the method, right? Um, well, do I want to do this? Pass symbol through. And I don't know if breaking the algorithm up is how helpful it is. But this is handle operators, I guess. Oh, you're not going to let me. Did I grab too much? Yes. Maybe this could just be passed through. Since I already say symbol. So if the symbol's a number, pass it through. Otherwise, handle the operator. It's really an operator. Just one. Okay, it may involve multiple ones on the stack. But, okay. And you can see the problem already. Like the lower level I get, the more it's like, if this were just this part, take out the set phase, take out the sleep set, take out the set phase, then the clarity would be up. It would only be 4 lines, pop a bunch of stuff and push. And now this looks a little bit, I don't know, it's a little crowded. But that's okay. So we handle the cases of equal operators and greater operators. Let's give one more conversion case. We'll put this in the middle. Let's see. Let's add divide. So we would expect 1 to 7 times 4 divide plus 3 minus. 1 to 7 times 4 divide plus 3 minus. And I don't know, I'll just mix it up. I haven't done any zeros. Okay. And let's make a 9 just to make sure we cover our numeric range correctly. And this is, I'll just say complex. 9 to 7 times, yep, 4 divided plus, to get the 9, 0 minus. I believe that is correct. And I often do something like this with these algorithms. You develop the pieces, you think, oh, it looks pretty good, and then throw one big hairy case. You sort of expect it to be green, but down somewhere in my heart, it's like, oh, I could still have a bug. I really need to check this. So that's what this does. And it'll fail because we don't have times. Oh, we do. We added times. Kind of preemptively, I guess you'd say. But, yeah. All right, we're just running tests. Yeah, I don't know. The claimed load is not so high. I'm going to take a little peek over here. Just make sure the right stuff is taking the most time. Windows server, like why would that be? It's a little weird, isn't it? You would think Xcode would be up there a little bit. Okay, I don't know. Odd. Okay, that does work. We're good. All right, so let's see. So we reordered variables and algorithm, added hard test case. All right, now if we had to add our next thing, let's see. So numbers pass through. So we're handling equal precedence. Things get popped because we're assuming left associative, and higher precedence. Things get popped. Stuff gets popped at the end. So we don't handle right associativity. And the change is if it's right associative, let's say I got arrow, meaning exponent, 2 to the 3 to the 4 is supposed to be 2 to the quantity 3 to the 4. So that first arrow, I need to pass through 2, 3, 4, arrow, arrow. So I don't pop off that first arrow after I've seen 2 to the 3 and a new arrow coming in. If it's left associative and it's equal, we don't do it. But I don't care as much about left associative. Like lots of languages don't bother with a right associative operator. But we do not handle parentheses. So let's, where did I leave that paper? Oh, I know the Google Wikipedia explains the algorithm. I remember that for sure. I believe what we have to do for a parenthesis is we give the left parenthesis a 0 priority, and we don't check for operators before we push it, maybe. In a right parenthesis, we pop until we hit the right parenthesis. I think that's the way it works. Shunting-yard algorithm. Okay, so 3 plus 4. Yeah, we want something a little more fancy. Yeah, you can see our illustration's somewhat like this one. You got the input, the stack, and the operator, the output, rather. We don't have the visual like the little Y-shaped thing. Okay, here's somebody's version of this algorithm. While there's an operator at the stack, if it's greater precedence or equal precedence and left associative, and it's not a left parenthesis, pop from the stack. This sounds more complicated. Let's see, what do they say about left parenthesis? Left parenthesis, push it on the stack. Right parenthesis, we pop while it's not a left parenthesis. Okay, they're handling function calls with parentheses as well. Pop the operator. From the stack and discard it. Okay, so we have to handle left and right parenthesis a little differently. We don't pop first, right? Because that's kind of what it's saying is make a new context where you apply all your rules. So if we had 4 times parenthesis 5 plus 6, the 4 goes out, the star goes on the stack, the 5 goes out. We're looking at the plus. No, we got a parenthesis in there. So, is this easy enough to read? I don't know. Let's find, I think, I edited the link the other day. They had a dead link, so I updated that. My contribution to Wikipedia. Okay, so here's the original algol translator for the X1. That's a machine making a translator for algol 60. Oh, I think I have that sitting in my folder for this thing. All right. Let's see. I don't remember if can we search in this parenthesis? That cannot be the only. Okay, if an opening bracket, parenthesis, is encountered, no emptying takes place. The bracket is put on the top with a priority number 0, thus shielding all postponed operations. Right, so it's always lower precedence than any. So we're only popping while it's higher precedence. We're not gonna pop that. Okay, so priority number 1 is assigned. Transport of operators from the translator stack to the object program takes place under control of the new priority number. When this stops, we find the corresponding opening bracket. The closing bracket is not put on the stack. The opening bracket is removed and go on. Okay, so we'll get the picture x equals AB begin equals A went out, 0 priority on the stack. So the plus comes in. It says, oh, I'm higher priority, nothing to pop here. Goes on the stack. The parenthesis, the B went out. The parenthesis comes in. We're going to pop until there. Yeah, okay. I think I can make sense of that. Okay, so let's start easy. 3 expected 3. Okay. It's going to have a -1. We'll really want to give it our own precedence. Now, he mentioned the right parenthesis. Did he ever put that on the stack? He said it never goes on the stack. Yeah. Yeah, adding the function calls definitely complicates things. Okay, and we expect this to fail. I guess they're not numeric, so they'll go on the stack. I think we'll see parentheses popping out, maybe right paren, left paren. I just don't know what's so slow. I mean, OBS is over there saying, I only need 5%, but when you're on top, it's running 30%. But still, that's 30% on one CPU. This is not the newest Mac in the world. Okay. Yeah, we got 3. Well, we got left paren, right paren. I guess the left paren is greater than or equal to the right paren because both are going to be -1. All right. So let's work on this. Okay. So we know we want left parenthesis to be 0. according to that. And the rule is if the symbol is left parenthesis, we're going to do something. Else, if the symbol is right parenthesis, we're going to do something. Else, we handle the operator as usual. Okay. If the symbol is a left parenthesis, all we do is push it on the stack. Whew. Output.add symbol. Wrong. How about stack.push? Stack.push symbol. Okay. Again, I kind of want to do the halfway thing, but I think this is going to automatically work. So if I see a symbol on the left of the stack, I gotta pop until I get a right parenthesis. And I think what he was doing was making the priority 1 on this thing so he could kind of use the same code as down below. Let's see. And so I got to adjust these up, I guess. I don't know. I'm maybe taking a step too far, but I don't think it's going to hurt in our case, but let's just do it. Okay, so if the symbol is right parend, well, you can see again, like this set phase is telling us what something wants to be. I'm going to do it stupid for now. Handle operator symbol. And I got to do stack.pop. Okay, because it's pushing it, and then I don't really want to push that symbol. Okay, but let's see if this works, and then we'll clean up. I miss inline because I could inline this operator, look at the last 2 lines and say I'm pushing and then popping, delete it, extract a new method in IntelliJ, Eclipse, ReSharper, lots of other places I could do that refactoring in a handful of keystrokes. This one, not so much. I'm expecting the test to pass now because we push the left parenthesis. We'll pass our symbol 3 through. We'll see the right parenthesis. We'll pop. Oh, I don't want to put them in the output. It is totally a different thing. Okay, let's just copy and adjust. Okay, I know that's going to break. So while the stack's not empty, precedence top symbol, that's fine. Output.add. I don't want to do that part. I just want to do some popping. And then I don't need to worry about this pop. All right. Because basically, oh man. It's really stacked at top, not equal to parenthesis. Okay. The stack is not empty. If it is, it's an error, but that's okay. If stack top, while the stack top is not a parenthesis, I pop, and then I do need to pop the operator. And maybe I just don't even have this justified yet. Maybe that's the deal. If it's a right parenthesis, okay, let's try this, and we'll grow this thing into pieces. I'm obviously not competent to do it in one step. If it runs anytime soon. I don't know if this will help. I may have messed things up. I don't know. I do expect it to pass in this incarnation. If the symbol's a right parenthesis, pop the stack. It assumes it's a left parenthesis on the stack. We know that's the case in this simple case. At least I would say I know it, but yeah, here it is failing. Crash. Namespace. Runtime. Pop remaining stack. Okay. I'll tell you what, we're due for a break. I'm gonna clean and kick off the test one more time because I was mucking with the environment while it was running. That's probably not good. But it seems like something something may have exceeded the stack for some reason. So let's take 2 or 3 minutes. See you in a couple. Welcome back. All right, the test did pass. So yeah, I must have messed with something environmental. Deleting stuff while it was running was probably not a good move. All right, so we only handle the case of left parenthesis, 3 right parenthesis. Let's generalize that case a little bit, and let's just throw a couple more on there. Make make sure we do it. Okay. Again, I'm not going to worry about unbalanced or anything like that. It's kind of a requirement that the input is already validated. Okay. And yeah. I mean, this should be done already. I just don't know what's going on. Someone said if you don't look at the test screen, it runs faster, but doesn't seem to make a lot of difference. I don't have that many tests. And the reason I think it'll work is because each left parenthesis is pushed, each right parenthesis is popped. Well, each right parenthesis forces the pop of the last left parenthesis. Now, we aren't handling this stuff yet, which says if I have parenthesis 3 plus 4 times 5 times 6, right parenthesis, I may have a bunch of other operators on the stack besides parentheses, and I need to get those popped. I don't want to pop beyond the stack, but yeah. Okay, gosh. Somebody I know uses a setup with a second laptop and sends the video out to basically to the input of the second laptop, and then uses the second laptop to just show that as the stream, runs OBS on the second laptop, and try and get the streaming cost off the main computer. But I don't know if that's the deal or not. But good news, that passed. All right, let's get fancier. All right, so let's do something like 3 times 4 plus 5. Let's do times 6. Yeah, that's probably a good challenge. Parentheses plus operators. Okay. I'll make this a divide just again so I can tell things apart. 3, so this should be 3, 4, 5, 6 times plus divided. Expected 3, 4, 5, 6 times plus divide. Okay, and I think this should fail because we'll get to our right parenthesis, we'll still have times plus on the stack, and we just pop the times. So I think we'll get 3, 4, 5 plus left parenthesis slash is my prediction. And the solution is we need that loop. So I think the loop really is going to be, well, the stack can't be empty if the stack is not a left parenthesis pop. So we'll get rid of those times pluses, and then we'll pop once to get the left parenthesis off there. But that's the code that failed before, I think. I may have messed up something, but and what I see is there's 3. Am I right? There's 3 places the stack gets popped. Yeah. So once one place we pop it is until we get something of higher precedence. The second place is we just pop everything. Well, and the third one, the new one, is we're going to pop until we see a left parenthesis. Now, would the higher precedence thing work? No, we still have to do an explicit pop. But I think what he's done is maybe he did make this work. Well, you could use the same condition if you got the precedence right between the operators and so on, but he's outputting to the stack, so we can't use that one directly. Can we use this one? Well, we could probably do something where we make up a precedence at the end. We make symbol be something with precedence -1, and then it's just going to pop until it's empty. But it's still outputting adding. Okay, we don't want it. It's different. All right. The failure should be. What did we say? Yeah, the parenthesis was in the output. The star was consumed instead of the left parenthesis. Not good. All right, but what we're saying is basically while the stack at the top, I mean, theoretically, if it's validated, oh, come on. I mean, I guess theoretically, if I'm going to run with the validation thing, if I know there was a left parenthesis, then while stack.top not equal left parenthesis pop off and then pop. Okay, I'm not going to check the empty because it theoretically can't happen. I'm always going to expect a left parenthesis. All right, let's see if this does the trick. But I'm a little bugged. Now there's probably tricks we can do. Like I could probably the stack top thing. We could probably put something of lower than 0 precedence on the bottom of the stack. And if top, right now top assumes, well, I probably could make up a bottom quote operator that I shove on the stack first of all, and then bottom's precedence is always lower than anything else. And then these two would become the same. We'll see about that optimization after the test runs someday. Well, let's see if I can find the bottom character. I always learn this sort of half a plus sign one from logic class. Well, that would be okay. I just want something to tell me it's the bottom of the stack, and I'm never going to pop it. Well, we'll do a search here while we're waiting. Bottom character logic. up tack. Okay, it does exist. All right. Oh man, it did not pass. 3456 slash is not equal to 3456 times plus slash. Well, 3456 slash. It's like the whole thing got consumed without being put. Oh, yeah, without being put out. Like I just ripped out all the code that wrote it out. Golly. Oops. Yeah, that's right. If while the stack is not a left parenthesis, pop the algorithm, pop the operators. Okay, we consumed them instead. All right. This is where I miss real pair partners because they keep going like, "You stupid! You just said to push it to the output stream." Sorry, it's like this thing of Babe Ruth, call your shots and call it a whiff, call a whiff. But I do expect it to pass. So the stack top is not parenthesis, left parenthesis, means I don't expect that we will output the left parenthesis, but just pop it at the end in 68. But I think I could get rid of these is empties on the stack stuff if I set up a precedence just right. I'm changing should the stack be empty at the end though. It should only have one element. Maybe stack.pop. I don't think you can push that, so yay. Okay. Handle parentheses. Now, I don't think there's. Well, let's see. Can we think of another case that would be complicated? I don't think we add anything. If we add more parentheses, let's do it just to make sure everything's kosher, and let's add times 2 at the end. 2 times. All right, I expect this to pass. I'm just making it a little more complicated. Make sure it picks up both parentheses and the times. The 3 slash and times are at the same precedence, so the slash should precede the times. So this will blow up if anything's wrong with pulling off the right parenthesis or something like that. All right, while that runs, I'm going to think forward. So my theory is I'm going to add this extra character with a precedence of like negative 99. Even negative 1 would be enough, but negative 99. I'm going to push that onto the stack at the start. I don't know if I can make init run this. And let's see what this does to the loops. Okay, this loop, stacked at top not equal left parenthesis, it doesn't affect it. The trick is, can I get rid of stack.empty? So if the precedence on the bottom of the stack is negative 100, it's never greater than or equal to any other symbol. We won't get the bottom symbol in the input. So the stack will never be emptied. So I think I can get rid of stack is empty if that's the case. And then this, that's the empty out one. Where's the other one? There were 3. Pop remaining. Same deal. I think if I said while the precedence, I almost want a second thing, I guess. That's why I made it 99. Okay. Our complicated case worked. So I'm pretty happy to call the parenthesis done. All right, let's update this. Today's the 26th. All right, and then the algorithm. Well, we didn't implement the whole thing last time. We let's see, for same precedence operators is as far as we got last time. Today, for different precedence operators, no spelling. Okay, these are left associative. And we did parentheses, which weren't too hard. I guess that is there. Okay. Algorithm. Should input and output be passed in? That's still an open question to me. All right. Let's, what we're going to do is, I don't know if you'd call it refactoring. We expect the same behavior for the same inputs. But it's kind of a replace algorithm, which is sort of a semi not a refactor. I mean, it's in the book. It's a real thing. You can do it, but it's taking on a little more risk than usual. But anyway, so let's put in up tack. This guy with precedence -1. Okay, and then I want to put this in the stack. Stack.push. Oops. This guy. And push runs in the main thread, so I think we're okay. All right. Now, if I do that, what's the consequence to these things? It doesn't affect this one because we're looking for a left parenthesis. It theoretically doesn't affect this one because we're not going to pop the bottom precedence will never be greater than or equal, so it will never get popped. It only affects this one. And so my claim what's my claim? It's not while stack dot is empty. Well, it's really while stack dot top not equal this thing again. Okay, so we're going to keep popping until we get all that, and then at the end of this I need to get rid of it, get rid of the evidence. Okay. Let's see. So instead of stack.empty, I'm popping until I see a bottom character on the stack, and then I just pop it because we're done. This is the last thing that happens. Okay, so this should pass tests. So this is yet another like flag type thing. I think I got to write that up as just sort of a little whimsy article, but lots of times you can throw in a sentinel and simplify conditions, and life gets better. And maybe I should be moving this up. Oh no, everybody blew up. Okay, Shunt-yard stack symbol unexpectedly found nil. So that's probably somebody hit the bottom. Let's run it and see what it does. That's why we have a visualization, right? Let us visualize. From the sound of it, even just one would fail. All right, does this fail? Starts one, done. Did not crash. Okay. 1 plus 2. Pass through 1, push plus 2, pop the plus, and that's done. What? Okay, so 1 failed. Clear failed. Oh, well, yeah, clear now leaves stuff on the stack. That one should fail. That line should have failed. But, all right, let's... What's weird is it's not really telling me where it actually failed. Stack.swift22. We've hardly even opened this code. Return stack.last. So top does not like to call when there is no top, but who... Make sure is empty, is not doing anything too stupid. Just says this is empty. Oh. Yeah, we really shouldn't be using that anymore. I guess my claim is that would be not necessary if I did this other thing. And so I should not do that. Okay, let's try again. I do think the clear method will fail. And maybe that should, maybe convert should just be responsible for pushing it and popping it. Let's make it do that. Yeah, that. Oh, no. Oh, it's still updating. All right, let's back up and try again. Let me see. Is this my history? Okay, let me keep this. Okay. Let's prefix converter. We will revert. Okay. All right. That should be no problem. Now I'm going to push it up here and pop it at the end. I think my test should all pass. Did I change anything in them? Oh, I added more parentheses. Okay, but that should still be okay. I gotta get more smaller commits. I get lazy on that. Now at this point, all I have is an extra precedence value that nobody's referencing. I don't think it should be a problem. What are we doing here? Refactor replace algorithm. Use bottom. Excuse me. Okay. All right. So I don't think it's an issue of the stack, per se. Let's get prefix converter. Okay. Let's find is empty. Input is empty is fine. Stack is empty. All right, let's add that thing on the stack. And we'll pop it when we're done. Okay. So now with that claim, I think we will properly have emptied our stack when we finish, but anybody who checks is empty, they should not be doing that. If I have plus on the stack and I've got times and I'm popping the stuff that's greater, plus is not greater. So nothing will be popped. We push the times. Okay. Stack.top not equal this thing, which is now going to be a constant. Let bottom equal that. Where did I do it here? Okay. Okay, I'm going to pop until I get the bottom character, and then I'm going to leave this with the bottom character in place. I believe that's correct. This one we're going to pop. I guess when would we pop something? Okay, let's push a 1 plus 2 plus 3. So 1 plus goes on the stack, 2 goes out, plus comes again. The precedence of top is plus is precedence 2. The precedence of the plus on the stack is 2. The stack is greater than or equal. We pop the stack off. Then we compare the top symbol. The stack top is now bottom. The symbol is now plus still. Is the bottom higher than symbol? No, it's not higher than anything. Okay. And then the other one, it already looks for a left parenthesis. Okay. I think this should be good. Cannot use instant, must be run. Oh dear. That's okay. I can make it static. Then I have to. You're not going to make me stay something dot? Yeah, here we go. How to make something good annoying. I'm sorry, I don't like that trade-off of that, and I'm surprised this is fine. Now you might say, oh, I should just do that in my own stack, and that might be worth doing. All right, that built. Let's run tests. And I'm trying to drive these things to similarity. Okay, because I think I can call precedence GE. I think I could do this, and it should be the same as that. But I think I might need a second character to cover this case to force it. We'll find out someday. Oh, well, this is probably not helpful at this point. Unknown symbols, theoretically, they don't happen. There's some duplication there, too. Now, I think this is where I was before, so I'm not sure what went wrong with this. Yeah, once the tests run, they're pretty quick, but gosh. All right. So now my claim is symbol. If symbol were forcing me to the bottom, okay. Let's add another one. Let's call this end of input, and it's got a precedence of -1, and let's make this one -2, so they're separate. I'm going to make another. And this end of input thing is very common. Let's see, I need a. There was one with 2 bars. Let's try that. Let's do this one just for. Okay. Now, traditionally, actually, in like algorithm texts, they usually write $ for that. You know, $ is the end of the input. And maybe that would be better. I'll follow tradition. We don't have $ in our expressions in whatever language we're doing here. Okay, so now I'm saying I should be able to say this. Precedence where symbol is end of input. Prefix converter end of input. Okay. So the stack top is bottom, and we're going to keep popping until it's greater than or equal to, no, while it's greater than or equal to end of input. So if it's less than end of input, we'll stop. Yes. I believe this is a valid refactoring. I mean, we're in a weird place. We are effectively changing the stack algorithm, or it's changing how we use the stack anyway. I'm trying to drive these 2 pop things. I want them as similar as I can get them. And right now, well, they don't have the sleep. We can add that. Yeah, this whole delay thing, like during the test, I would like to change it to, almost nothing. But the difference I see in my loops now, pop remaining stack delays inside the loop. It sleeps, it output adds, stack top, it stack pops. So this chunk of code seems like it should be the same. And this happens, I don't know, it almost, yeah, at least this will be a function call. I don't know. We'll see. Assuming it passes. All right. And then the next refactoring, this thing we said earlier today about the input queue and the output queue really don't necessarily belong to the Shunt-yard algorithm. They almost seem like inputs and outputs that should be passed in. Yeah, I think all the delay is something about setting up the runtime environment. I don't know why they can't leave it there and then just kind of pop into it, but they don't seem to have some like hot update kind of capability is not part of this. Like there the tests actually start and then boom, it's done. So it's not the body of the test, it's something environmental. All right. Well, this is we're out of time. But notice these things are very similar at this point. I'm